Question 2 of this exercise says solve the problems given in example 1. And in example 1, we had represent the following situations mathematically, and we had these two situations, 2-word problems. So we had to represent those mathematically, and then now we also have to solve and find the unknown in each case. So let's start with the first part. So the first part says John and Jivanti together have 45 marbles. Both of them lost 5 marbles each, and the product of the number of marbles they now have is 124. We would like to find out how many marbles they had to start with. So let's say that this is John. So I always like to make these drawings because it helps think quite clearly. So let's say this is John and this is Jivanti, and initially they have 45 marbles together. So let's say that John had X marbles, which means that Jivanti would have 45 minus X marbles, because the total of their marbles should be equal to 45. Now both of them lost 5 marbles each. So now John will have 5 marbles less, so he will have X minus 5 marbles, and Jivanti will have 45 minus X minus 5, which is 40 minus X. So Jivanti will have 40 minus X marbles now. And now the problem statement says the product of the number of marbles they have now is 124. So this means that the product of this number and this number should be equal to 124. And this fact is what will enable us to form a quadratic equation in X. So we have that the product of X minus 5 and 40 minus X, this should be equal to 124. So let's simplify this and see what we get. So expanding the product on the left hand side, we have X times 40. So that's 40X. Then we have X times minus X, that's minus X square. Then we have minus 5 times 40, that's minus 200. And then we have minus 5 times minus X, so that's 5X. This is equal to 124. So shifting all the terms on the left hand side to the right hand side, we will get minus X square will become X square. Then we have 40X and 5X, that's 45X. When it goes to the right hand side, it becomes minus 45X. And then minus 200 becomes plus 200. So 200 plus 124 is 324. So X square minus 45X plus 324, this is equal to 0. And this is the quadratic equation that models the given situation. Now to solve this quadratic equation, what we will do is we will use factorization. So we will split the middle term, and to split the middle term, we have to find two numbers whose sum is equal to minus 45 and whose product is equal to 1 into 324 or 324. So we have to find two numbers, let's say P and Q, whose sum is equal to minus 45 and whose product is equal to 324. So if you think a little bit about the factors of 324, we see that 324 can be written as 18 into 18. It can also be written as 9 into 36. And 9 times 36, 9 plus 36 is 45. So the two numbers P and Q, whose sum is equal to minus 45 and product is equal to 324, are minus 36 and minus 9. So you can split this middle term minus 45x as minus 36x minus 9x. And now the quadratic equation becomes x square minus 36x minus 9x plus 324 equal to 0. And now we can factorize it and solve it. From the first pair, take out a common factor of x. So we get x times x minus 36. And from the second pair of terms, take out a common factor of minus 9. So now we will be left with x minus 36, and this is equal to 0. Now we have this common factor of x minus 36. So let's take that out. So we get x minus 36 times x minus 9 equal to 0. And from here we can get the two roots of the equation. So the two roots are the 0 of the first term, so that's x equal to 36, and the 0 of the second equation, so that's x equal to 9. So our answer is that John had 36 marbles and Jivanti had 45 minus 36 or 9 marbles. So we can write the answer like this: John had 36 marbles and Jivanti had 9 marbles to start with. But the other solution is also possible. If I take, instead of taking x equal to 36, if I take x equal to 9, then John had 9 marbles to begin with and Jivanti had 36 marbles to begin with. So because we are not told who had the higher number of marbles or who had more marbles, both of these answers will work. So what we can say at the most is that the two of them had 36 marbles and 9 marbles respectively, and we don't know which one had how many. So the two answers possible are John had 36 and Jivanti had 9 marbles, or John had 9 marbles and Jivanti had 36 marbles. And we can verify that because the original number of marbles are 36 and 9, if both of them lose 5 marbles each, then the new number of marbles are 31 and 5, or 31 and 4 actually, and the product of 31 and 4 is equal to 124, which is what is given to us in the problem statement. So the answer is correct. In part 2, the problem statement says a cottage industry produces a certain number of toys in a day. The cost of production of each toy was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was rupees 750. We would like to find out the number of toys produced on that day. So the unknown is the number of toys produced on that day. So let's say that the number of toys, let's represent the number of toys produced by x. And now we have to form a quadratic equation in x. So what information are we given in the problem statement? So the problem statement says the cost of production of each toy was found to be 55 minus the number of toys produced in a day. So we can write the cost of production per toy. This will be equal to 55 minus the number of toys produced. Now, so this will be equal to 55 minus x. So you have to be a little careful in writing this expression, because I have seen many students write this as x minus 55 instead of 55 minus x. The problem statement clearly says the cost is 55 minus the number of toys. So 55 comes first and then x comes. Okay. Now the other piece of information that the problem statement says is that on a particular day, the total cost of production was rupees 750. So the number of toys produced was x, the cost per toy was 55 minus x, and the total cost was 750. And this means that the product of the number of toys and the cost per toy, so x times 55 minus x, this should be equal to 750, and this is how we get our quadratic equation. So let's simplify this, write it in the standard form. So we have 55x minus x square on the left side equal to 750. Let's take the terms on the LHS to the RHS. So we get x square minus 55x plus 750. This is equal to 0. Now to solve this quadratic equation, we will split the middle term. To split the middle term, we have to find out two numbers whose sum is equal to minus 55 and whose product is equal to x squared, the coefficient of x squared times the constant term, so 750. So by the way, I missed this 0 here, so this is the equation. So now we have to find out two numbers whose sum is minus 55 and product is 750. So a little thinking will show you, if you think about the factors of 750, you can see that 750 is 25 times 30, and the sum of 25 and 30 is 55. So the two numbers which you need to split the middle term are minus 25 and minus 30. So you can split the middle term as minus 25x minus 30x. So let's do that. So we will get x square, and then we split the middle term minus 55x as minus 25x minus 30x, and then we have plus 750 equal to 0. And now we can factorize this by taking out the common factors from each pair. So from the first pair we can take out x, so we get x times x minus 25, and then from the second pair we take out minus 30, so we get minus 30 times x minus 25. This is equal to 0. Or now we have this common factor of x minus 25. Let's take that out. So x minus 25 times x minus 30, this is equal to 0. And now we can find the roots of the equation. So the roots are x equal to 25, which is the 0 of the first linear factor, or x equal to 30, which is the 0 of the second linear factor. So the number of toys produced on that day could be either 25 or it could be 30. If the number of toys produced was 25, then the cost per toy would be 55 minus 25 or 30, and the total cost would be the product of these two numbers, which is 750. On the other hand, if the number of toys produced was 30, then the cost per toy would be 55 minus 30 or 25, and once again the product of these two numbers is 750. So both the answers work. The number of toys produced on that day could be either 25 or it could be 30.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.